Sorry about that. Hello and welcome to this Houdini live session. So first I will explain what I have in mind for this session. So I'm building a roulette system for shorts. So I won't explain it there because you can probably, if you want, find information on my channel about that. But yeah, I figured that since I need since I'm building a roulette system, and since I will need I might show the roulette on the thumbnails, and a roulette is a nice procedural setup to build in Houdini. And yeah, I just wanted to do that. The advantage of building it in Houdini and having it procedural, it's not just for fun for me, but if I want to put in some new characters, because see, I have to explain a little bit. The roulette is a roulette of ChatGPT personas, and if I want to make new characters come in, I will probably need a bigger roulette. So that says procedural to me, because we can start at 6 and then move to 7, 8, 10. Yeah, so let's do that. I hope it will be a quick one, and that we will be able to finish it before the temperature is unbearable, because we are still in the heat wave, so stream time is limited. All right, so let's go. And one sec. Okay, so I kept the same project as the one where I built the ChatGPT logo, because it's pretty related. So I wanted to share first, I'm still inspired by Slay the Spire, and sorry, I noticed that my desk mat is showing on the bed, and I don't like that, so let's move it. I had it right there because I did spill some water onto it this morning. So okay, yeah, we will start with a circle, and we can use the sliced arc in order to have it sliced like a roulette already. So yeah, I wanted to show you the Slay the Spire roulette. Where is pure F? There it is. So this is something we're inspired by. We are aiming at doing that. So we will need... Actually, there was some kind of pointer, and in the game, when you play this roulette, there is something that I don't know the term, but that slows down the motion of the roulette. I'm surprised that I don't find it there. So yeah, it is on this screenshot, so I will grab it for the reference board. Sorry. Yeah, I like the shape of the thing that slows down the roulette. All right. So let's move back to Houdini. So we will need a global divider that will be the number of slice we will want. So we will make a little controller. I'm supposed to have a recipe. No. What? Did I lost my recipe? Let me check in the recipe manager. Windows recipe manager. So maybe I didn't call it control. Let's decimate for it. Clue, clean points. Okay, maybe I built it at a client or something like that, because it seems that it's not there. Okay, it's not a big deal. Let's just make a null object and change the shape to a circle because that's what I'm used to. And make it blue. All right, so we will add a parameter and it should be an integer. Oh, I'm so used at looking for floats that I always miss the integers. So the name will be slices, label slices as well. Range 0 to, I don't know, 20 seems like a lot. 12 I think is the max persona I want. So, and let's put it at 6 at the moment. This number will be referenced a lot, so that's why I build it into a controller. Okay, so we want our roulette to be quite not polygonal. We want it to be a circle, and I think let's say the minimum division we want for the roulette will be 5. So if it's, we will work with 6, and no, let's check with 4, and then so we'll copy this parameter, paste it in there, and now we want to have a circle. So this is the minimal version, and we will just multiply until we have something that is close to a circle. I think 12 should be good enough. Yes, it looks like a circle. All right, so, and now we can change the number of division like so. So now what I want to do is to define 6 groups that will be our slices. So we will do the group by range. No, I'm obviously typing it wrong. Range grouping, group by range. I always forgot what's the difference between those two, but I think it's the second one I want. Select select 6 out of no, select 12 because we multiplied by 12 out of 6. We'll have to input a name. Actually, I don't think we will do that with grouping because I'm not sure it will work. Okay, why is it points? I want at least it. Yeah, this can do it, but I think having another attribute will be more convenient. And the attribute we want is simply the primitive number divided by this controller. So so this is a prim rangle, and our attribute is slice. It's an integer. E at slice equals so we will have to reference the controller in a parameter. So we probably need to no, we probably do not need to anything. So slice okay. Obviously it's not working if I don't have that. So this is at num. Okay, I think this is correct. Yes. So based on that, we can assign colors. It already did in the visualization. But oh no, it did. No, we have to. Yeah, it did bring our multiplier, not the number of slices we have. So yeah, we will definitely add another parameter in there, and it's another integer, and this one is the multiplier. Okay, so we set it to 12. Just quickly checking that I'm indeed live, but I think I am. Yes. Okay. So here we will copy that part and go there, and it's not slice but mult. Okay. And there we reference mult and not slice. Okay, so just to be exact, I will change the expression, destroy this parameter, and rebuild it. Okay, so okay, so now we have our slices. This is the first step. What I will need to do, one sec, there is noise in my home. Okay. What I want to do is have circles on the slices that will hold the picture of the persona that I will bring. So we will need 6 points, and we will need the rotation. So we can start from the same circle, except that we will not multiply it by the same value. Okay, so just the slices, and we will need to rotate it based on, so each slice has an angle. We need to find half the value of the angle of the slice. So this will be, I guess there are some expressions to do radians within rotation, but I'm not sure how to use those. So so it's rotate. It will be 360 divided by yes, and all of that should be divided by 2, I think. No, this is not what we're looking for. Okay, I will copy this expression so that we'll find the value by A. Okay, I think I'm not on the correct piece of geometry. So yes, all right. So this was the catch, and I think this this expression is correct. Let's quickly check by, and we will just scale it down. Okay. Maybe merge those instead of just looking at them. So we will just move this a little bit towards the camera. And then merge. Okay. And let's check by changing the number of slices. Yes. Cool. So now we will have to do some some math that are like from low level math, but still fun math. Because we will copy circles on those points, and we need the circles to be inside the slice, and we could just make it with our eyes. But we could also just do some perimeters and things like that. So, but first, let's undo. No, not undo. Let's only keep the points that we will use for the copy to point. And we'll do it with add the geometry, but keep the points. And we will obviously remove the center. What's the best way to do it? I think I can just blast 0 because the center will always be 0. Okay. So let's just use another circle. Not this one. Let's copy this one. Let's see. If I start by pasting that and then multiplying it by a value, let's say a third. Actually, but I don't think that will allow us to have it respond to the... It's working now, but if I up the slices, I don't think it... Yeah, obviously it should be responsive to the so for that we need to use the perimeter to approximate the circle's radius. So how do we do that? I think we can keep the distance constant relative to the size of the circle. It's not supposed to move, so we can just keep it at a fixed value. I mean this value. But so this makes it so that we have our circle. Let's duplicate this one. We have our circle. Let's multiply it by 12 once again so that it's a nice circle. We know that the points where we will be cloning our circles live on this this perimeter. So we know that we can easily have the perimeter calculated. So it's 2p. Yeah, the global thing is 2p. So a section of this perimeter, which is an approximation of the radius of the circle we want, would be 2p divided by the number of slices. So let's make a note so that I remember what I'm doing. 2p divided by slices. And yeah, that's it. There's not really need for more. So and then we can probably just so if I use this value, it will be responsive, and then we can dial a fixed value for the padding, and we will be okay. So what was that? Okay, so I copied something pretty random at that moment. So what we want is slices. So we want to, I think you can call p in expressions, but I don't remember how, so we will just approximate the value. Okay, so divided. And all of that will be multiplied by a value between 0 and 1. Oh, or we can simply, so this should be responsive now. So if I move up, we were at, sorry, 1.04. Yeah, so, okay, so it is. So now we don't have to, we can simply use the radius to be our multiplier. It's not working the way I expected, and that's because Yeah, I think it has something to do with the fact that I was thinking on the perimeter, which is kind of linear. It's not squared, and I should have been thinking squared because we are on a surface. So to be squared, we need to use the value that I said earlier was fixed, because using the second value will make it square. Like, I was on only one axis until then, and now if I move the circle, the cloning circle position, this will make a two-axis thing, and I will be able to reflect the changes in the. It's clear in my head, but I guess I'm not being clear at all right now. Okay, but I will do it, and then it will become clear, I suppose. But how do I do that? That's the big question. So we need to work with this one. This one needs to adapt. So the more slices you have, the more it's close to 1. And the less slices you have, let's say we have 4, the more it's close to 0. Okay, and now it's not moving with because in my formula I did not include, I used the fixed value like I said I would. So right here, so this shouldn't be fixed. Except that it's exactly the same. I don't know exactly what value I should use. I need to think. Okay, I will need to grab some paper. Pen. Sorry, it's not very interesting for the live, but I will try to explain my thinking. I should probably do that on some kind of whiteboard, but at the moment I don't know how to use any, and I think better with pen and paper, so maybe I will show you just what I wrote down. But I think this problem is more complicated than what it looks, but I think we can approximate, or maybe we can simply make a parameter that will allow us to move the... Yes, we will. Okay. Let's move back to the mouse and keyboard. So let's build the distance from center parameter. Okay. Edit parameter interface. This time we need a float. We'll call it dist and label it distance from center. Okay. Let's copy the reference and paste it in there. Now we have this parameter that allows us to move the circles, and we can use it now to reflect the size of the perimeter in the other expression. And this is which one it is already. Oh, I forgot the R in the 2PR formula. So this assumed that the R was always 1, but the value the slider we just created is the R. So let's input it in there. Okay, so now it's super big, but is it responsive? It's not. I did something wrong. Oh, I just didn't link it to the circle. I did. Yeah. So that's not the problem. Why? Okay. I didn't paste the correct expression. Okay, so now it's copied. It's not copied. Okay, so we'll copy this part, paste it, and then change it for dist. What? Why are you unhappy? What did I do wrong? Tell me. I need to know. Okay. Are we good? I don't know. We'll soon find out. So now the sizes of our circle are a function of the distance from the center, which will make it a 2-slider procedural setup, not a 1-slider. I think it's possible to build it in one, but it's not that bad. I think I will be happy with that. So we will need to adjust, not that much, please, the values a little bit, like so. Okay, so now if I want 6 slices, I can simply, oh, it's a 3-slider setup. Boo, boo. You can do better than that. If I want a 12 sliders, oops. Okay, so I think it's absolutely possible to reduce the number of sliders, but this involves some mathematical reflection, and I'm starting to be a little hot in there, so I will just accept the fact that this is a 3-slider setup, and we will just bring in the slider for the diameter, the radius. Yes. Okay, so add a float. This will be called the radius. Oh no, I forgot the capital letter. We'll copy paste it the other way around so that we can keep the value, since this expression can work both ways. Yeah, but no. I'd rather have it clean there and have the expression there. All right. So we said that we needed 6 slices at the moment. Oh, slices. I made the typo. I cannot live with that. This is way too awful to be accepted. So slices, that's way better. All right, so now, so the fun part is over, I think. Now it will be modelization and shading. I will move forward a little bit with that, but I think I will end the stream before complete this process completion, because I need to cool down. Okay. I think we can get rid of that. So, and template this thing. Let's assign color based on the attribute we built that is called slice, I think. So we can use the attribute adjust color, I think. Okay. Attribute class primitive. Operation button type remap attribute. The attribute we want is slices. Yes. Maybe you can't compute range. Yes. You can we can assign specific values, which is probably what we will do. But for now, oh, cool blues. No. I didn't know that you had color palettes available right inside Houdini. So we can probably paste our slice number. I wonder how much colors there are in the color palette. So numbers of colors. Are you okay? I don't know if it's okay. Let's just move this to check. But yeah, this works, but the color palette, maybe you need to... Okay, so if you choose a color palette, you assign a color number, a number of colors, sorry. But if I... and it commands the slice number. All right, I mean, this is to be expected because of the channel function, but yeah, okay. Let's keep it at 6 at the moment. We'll probably need to find a better way for the to do the colors, but let's roll with that at the moment. You will be some kind of purple, and you will be some kind of pink, and you are too dark, so you will be some kind of orange. All right, maybe brighter orange. Okay. Let's roll with that for the moment. So now extrude. I'm thinking about how I should approach the thing. I think we can simply have the circles on top of the slices. So I will remove this one and do that by match sizing. This probably needs to be extruded too, but just a tiny bit. Now let's move it on top. So it's on the Z that we want max to min, no, min to max. What? Oh, I'm max to max. All right. So, okay. Looks okay. So we will need some what's the name? Some little spikes right there to make the slowing down process visible. I should have said the slowing down infrastructure visible. So for that we will grab this same. I wish I could have it. So this time I think I can keep it. So transform value 0.9. Add we blast the center like we did earlier, and now we can group by range. This time select one out of slices. So this is we'll call that slow, even if it's a terrible name. So now we have our points for the copy to points. We will just quickly do a little tube for the radius scale. It should be something like 0.04, I think. End caps, yes. Height 0.04 seems big. Height, I think we need 0.1. No, that's too much. Okay, 0.06. Yes. All right. So now, since we want to copy it at the bottom of the point, I think I will just matchize it so that it sits on the x-axis. Anyway, I need to orient it correctly first, so it needs to be oriented in C for the copy to point to be correct. Geometry to copy. Let me check that the orientation is correct first. Looks like it is. So now it needs to sit the minimum of, oh, I already had the match size, my bad. Let's merge. Okay, so now I will just match size now and make it the same way, the same type of the. Yes. Okay, so 0.9 is not enough. 0.96, 7. Oh, I forgot to use the group. Slow, yes. Hey. Oh, I took the wrong parameter. It should have been the multiplayer and not the slices. So the group is there. Okay, so this is a little too high and a little too thin. So I said too high and I upped it. So, okay. Just for the pleasure, let's. Oh no, my colors are not procedural. You know what? Let's see if we can do this with attribute randomize rather, so that we have a nice procedural setup. So I want the color to be on the primitives and I want to use an attribute. Can I do that? Distribution. If I use attribute from group, I think there is a node like that. A labs node from attribute from group. Because I obviously can do it in Vex, but I probably can do it in. Oh yeah, we will do it in Vex quickly. So what we need is a primitive wrangle, and we need 3 random values. So float round R, because we will do random values with different seeds for each color, and then set the color to the 3 random values. Float round R equals round the at slice plus seed R. Oops, what did I do? What? So this will be round G, this will be round B. Okay. At cd equals set B. We did it. So let's check that out. Yes, it's working. Still a multi-slider setup, but at least we have procedural colors now. So we hit the 1 hour mark, and I think that's the max I can do right now with the hit. And I think that the core of the roulette is there. The fun part was the procedural part, in my opinion, and this I shared. So I will just turn the AC back on and finish tweaking this in a much more friendly environment to me. And yes, I was happy to share that with you, and hopefully you find it fun as well. And I'll see you. Sorry,